So we're going to talk about equations of tangent and cotangent from the graphs. I think what's very helpful for this is having a good sketch of tangent and cotangent in front of you where you've also marked some of the key points and the asymptotes. You'll see why, and then also just a reminder of how to find the period and the asymptotes. So all the graphs in this video I've taken from Desmos.com, which you guys know I think is the greatest graphing website ever. Okay, so let's party on here. So I've got this first graph, so I have to figure out, first of all, do I think that this resembles tangent or cotangent? Okay, so notice that it's going through 0, 0, so that feels kind of like tangent. And then these asymptotes, so there's one on each side. So this is a little bit different from the graph of tangent. It's like the asymptotes have been moved in a little, but on the whole, it kind of feels like tangent, right? So I am going to conjecture that my function probably takes this form. Okay, so now I have to leverage what I know about these asymptotes. So this is the typical form of the asymptotes, but we have to reverse engineer this a little bit. So in this case, I have that my asymptotes came out to negative pi over 4 and pi over 4. So think about how you usually work with, so before we write anything down, or I just want to sketch out an idea here. So normally what I would do is I would set up this equation bx equals negative pi over 2, and I'd have something plugged in for the b, right? I would plug something in for the b, and what that would ultimately give me is the form of my asymptote. So I would solve this. I would solve this to get x equals negative pi over 2b, and I know then that this would come out to negative pi over 4. That's how I interpret this information. So this would equal negative pi over 2b. Okay, so this is really like the form that we want to use to figure out b. So I'm going to go back to where I was just talking about my asymptotes. So I could just make a little cheat sheet here. So for graphs, what I'd want to do is I'd want to set this equal to x equals negative pi over 2b, where x, this is an asymptote, so you would plug that in. So take that information as you'd like. Okay, so let me erase all this for a moment, and now let's set that up, because we've kind of figured out how are we supposed to approach this. Okay, so I've got negative pi over 4. Now that's got to equal negative pi over 2b. So if I reverse engineer this now, I should be able to figure out what my b is. So to figure this out, first I'll multiply both sides by b. So now I've got b times negative pi over 4 equals negative pi over 2b. And then to finish this, I get b equals negative pi over 2b times negative 4 over pi. And so if I solve that, I get that my b is equal to 2. Cool. So now I figured out what my b is. So let's see, I'll just note that here. b equals 2. All right, so now let me just get rid of all this. And so now the question is, do I have to plug in anything for a? So we don't have like a nice formula to solve for a, or do we? Okay, so you could actually figure out if you need anything for a by using the information on your graph. Now, when you're selecting points to use, I wouldn't recommend that you choose 0, 0, because you'll see why in a second. You won't get any meaningful information. Let's use this point here. So I've got my y in this case is 1, and then we just found that b was equal to 2. And then I can plug in pi over 8 for x. So if I go through and I solve for this, so I get a tangent of pi over 4, and so that equals 1, right? So then this becomes a times 1. So a just equals 1. So now I have everything that I need for this. So this becomes y equals tangent of 2x. So that is the graph that we're looking at here. Okay, so moving on to our next graph. So this I think gets pretty tricky actually. So you might look at this and you might think at first, oh, this is tangent because it looks like it's shaped like tangent. So this one, you want to look at your asymptotes to help with this because your asymptotes actually go between 0 and pi. So that's kind of a big hint there that this is not actually tangent, it's cotangent. But I'll tell you one other tricky thing about this. So it's going to be cotangent. The thing is, so cotangent normally looks like this, but so the A in front of it must be negative, because when it's negative, when this is negative, that will flip the graph upside down. So if this is negative, then this graph flips upside down, and then that makes a lot more sense as to why this graph is going the direction that it is. So hopefully that makes sense. Okay. So now I want to figure out what's my B. So we've talked about kind of how to reverse engineer that. So I'll walk you through that one more time. So let's use bx equals pi. So normally, so just think about how you usually do this. Normally you have a b to plug in, and you plug in that b and then you solve for x. And when you solve for x, you get bx equals, and when you solve for x, then this would be the math that goes into that. Now, in this case, I know what my asymptote is. My asymptote, I can see it here. It's equal to pi. So rather than having this equal to x, I want to have this equal to pi, and then I can just go back and solve for b. So this becomes b pi equals pi, so then I get b equals 1. So in this case, I get my b is equal to 1. Okay, so let me get rid of all that. And now let's keep going. So now I got to figure out what is my A. So I would recommend using a point that does not equal a 0 so that you get more meaningful information. So we're going to use this point here. So I'm just going to plug it in now. So I have 4 equals A cotangent, and then my B is equal to 1, so I can just drop it, and then this is 3 pi over 4. Okay, so what is 3 pi over 4? 3 pi over 4 is equal to negative 1. So what I get then is negative A equals 4, therefore A equals negative 4. And that makes sense, right? So I just told you that A must be negative because this must be cotangent flipped upside down. And now we've actually seen that, yep, that is exactly what happened. So the equation here is negative 4 cotangent of x. Okay, so up next. All right, so what do we think? So looking at the asymptotes as a guide, what does it look like this graph might be? Well, now we've got this shape of cotangent, and then our asymptotes are between 0 and that looks like pi over 6. That's what this dot is telling me here. So I feel reasonably confident that this is a cotangent of bx. Alrighty, so now let's go ahead and solve. So I'm going to have here, so remember, I would normally have my bx is equal to pi, and then normally I solve for x, and I would get this. But now what I should have is that pi over b, this is going to equal the value of this asymptote, which is pi over 6. And so now I can solve for b. So I can multiply both sides by b, so I get b times pi over 6 equals pi, and then I can divide to get b equals pi times 6 over pi, which equals 6. So I have my b is equal to 6. So I can get rid of all of this good stuff, and now we can keep going. Okay, so now we have something a little interesting here, and there's a little bit of a hint in these points. So normally we have one of our key points going through the x-axis. And in this case, notice that our points have been kind of lifted up. So it looks to me like we've got a translation here. So those are totally possible. So just to remind you, here's the graph of cotangent, and you'll be shown like the 3 key points. And so if you notice that those points have moved, then you can go ahead and take the creative license, if you will, that these must be dealing with a translation. So does it look like these have moved up, down, left, right? It looks like that they've just moved directly up, really. It looks like they've been moved up just once. Normally I had a point here that would have hit at 0, now it's been moved up 1. So I'm going to say that this is 1 plus a cotangent 6x, and now I should be able to figure out what does this a actually equal. So let's see if we can figure that out. So I'm going to plug that point in. So I get 2 equals 1 plus a cotangent 6 times pi over 24. So I can go ahead and I can subtract off the 1. So I get 1 equals a cotangent pi over 4. And cotangent of pi over 4 I know equals 1. So I have 1 equals a times 1. So that means that a just equals 1. Okay, and so now we've figured the whole thing out. So this becomes y equals 1 plus cotangent 6x. All right, so that's just a couple of examples to kind of help get you started. So that's it for this video, guys. I'll see you in the next one.